Okay, so here's the computer output for our example, online sales and time spent on the chat feature. And this was using the programming language R. Now I could have used Python or Excel, and later on in the course we'll use Excel. But here is R, and the output for this, so I entered in the 5 data points, the 5 customers. I had 2 columns. I had a column for the X's, the time spent, and a column for the response variable Y, the online sales. So you can see there's the LM stands for linear model. It says, hey, you just ran a linear model, you ran a regression. And here are the 5 residuals. Right, 5 customers, so there'll be a residual for each one. So remember, it's y minus y hat are the residuals, and the first one, the fourth one, and the fifth one are negative values. The second one and the third one are positive, and that is consistent with our residual plots and also the plot with the least squares regression line. 3 of those data points were below the line, 2 are above the line, so that is consistent. The coefficients, so we calculated these, and we'll see how well we did. We have an intercept of 75.2, and that is very close to what we got. The X is our time spent, and we calculated the coefficient to be 0.519, so that's very good too. So that is our B naught, and this is our B subscript 1, the slope. So the intercept and the slope values are good. In the next column are the standard errors for those coefficients. For the intercept, it's 4.5, and for the slope, it is 0.06544, and that is what we calculated. And then we also calculated 7.934, something like, it was very close to that. So that's good. There's a little bit of rounding difference there. But most importantly, we want to know, is the slope coefficient, do we reject that it is equal to 0? And we do. We accepted that it is not equal to 0. It is statistically significant. And so that means that time spent is significantly associated with online sales. So this is good. This is what we want to find. We want to reject the null hypothesis that it's not equal to 0, that it is, and accept that it is different than 0. And then we can conclude that the predictor variable time spent is significant in predicting online sales. So that's what those stars are. The more stars, the better. So we have 2 there. So we know from the p-value 0.004, we calculated that it was somewhere between 0.002 to 0.01, and so this is the exact p-value, which is good, and that falls within our range. Now the standard error, well, it says here the residual standard error, that is our standard error of the estimate, S subscript E, and that is what we calculated as well, 4.38 on n minus 2 degrees of freedom, which is 5 minus 2 gives us 3 degrees of freedom. The multiple R squared is that capital R squared, and we also calculated that 0.9545, right? So that's good. And the F statistic, we haven't calculated it yet. We will in the next video, and it has 1 and 3 degrees of freedom. But I want to point out to you that the p-value is always in simple linear regression. The test for the overall model for the F will always have the same p-value as the slope coefficient. Okay, so in the next video, we'll see how to conduct the test, the F test for the overall model.